Hi, this is Jo from Math Tutor Me. This is my second lesson on surds. Last lesson we looked at simplifying surds, so hopefully you've had a look at that and you're feeling pretty confident with that. Today we are looking at adding and subtracting surds. Now you can only add and subtract surds if they are what we call like surds. Now what that means by like surds is that the number underneath the square root sign, if that number is the same, then we say that they are like surds and they can be added together. So these ones in question 1 are all like surds. They are all square root 5s. So all we have to do is to take the numbers in front of those surds and add or subtract them together. So I have a 2 root 5 plus 4 root 5 minus, now if there's no number there, that means that that is a 1 root 5. 2 plus 4 is 6, minus 1 is 5 root 5s. So the surd doesn't change, but we add and subtract the numbers in front. Let's do it again for the second one. We have 6 square root 3 plus root 2. They are not like surds. Minus 3 root 3, well, this was a root 3, and this has a root 3, so they are like surds. Now, I've circled it to show you the ones that are the same, but when I circle it, I also circle the symbol in front of the surd because that tells me that I have to subtract. I have to do 6 root 3 minus 3 root 3. 6 minus 3 is 3. Root 3 doesn't change. I still have root 2, which would be a 1 root 2, plus 5 root 2. They are like surds, so 1 plus 5 is 6 root 2. Okay, when we look at question 3, all of these numbers are different, so it's tempting to say that they are not like surds. But before we can know that for sure, we have to simplify all of these surds using the strategies that we learnt last lesson to actually make sure, to see if they're like surds or not. So to do that, we need to know all our perfect square numbers. So it's always handy to have those written on the side of your page. So I'll just quickly write those down. Up to 100 is all you usually need. So let's look at the first one, square root of 8. 8, I need to divide by a perfect square to simplify it, so I can divide 8 by 4. So let's change 8 to be 4 times 2. Let's do the same thing again. Let's not finish that one yet. We're going to go to this second one and split it as well. 18 is the same as 9 is my perfect square times 2. 32 can be divided by 16. 16 times 2 makes 32. Our second step for simplifying surds is to break each of these surds into 2 surds. So breaking it in half like that. So root 9 times root 2 and root 16 times root 2, and then we square root each of our perfect square numbers. So the square root of 4 is 2 root 2. The square root of 9 is 3 root 2. The square root of 16 is 4, and the root 2 sits afterwards. Now that they're all simplified, we can see that they are all like surds. They are all actually root 2. So we can add and subtract. 2 plus 3 is 5, minus 4 is 1, root 2, or we can just write root 2. We don't want to write the 1 because that's adding in more things than we need to, and that wouldn't be as simplified as possible. So root 2 is our final answer. Let's have a look at a few more. Leave our square numbers here on the side. Okay. Question 4, we have 2 root 27 minus a half root 12 plus 4 root 48. Let's go through and simplify everything. Leave the 2 sitting out the front. 27 can be divided by 9, so let's break that to be 9 times 3 makes 27. For the second one, leave the half out the front. 12 can be divided by 4, my perfect square, so that's 4 times 3. And for my third term here, leave the 4 out the front. 48 is the same as 16 times 3. Okay, next step is to split each of those surds in half. You may find, if you've been practicing your simplifying surds a lot, that you might be able to start skipping a few steps. You might find that you can go straight from your first line, your question, you might be able to go straight to this line. But I'm going to show all the steps just to make sure that everyone can see how this is done. So now I want to square root each of my perfect squares. So it's going to be 2 times square root of 9 is 3, root 3 sits after it. Minus a half, square root of 4 is 2, and the root 3 sits after. The 4 out the front, square root of 16 is 4, and the square root of 3 is at the end. Let's just tidy up those numbers. 2 times 3 is 6, root 3. Half times 2, or half of 2, is a 1, so it'd be minus 1, which I can just write as minus root 3. 4 times 4 is 16, root 3. So they are all like terms, they're all square root 3's. So 6 minus 1 root 3, which is 5, plus 16 makes 21, root 3. All right. I put one more question in here to show you that you can have as many surds added and subtracted together as you like. You can get as messy as you like, but we can still stick to our same method to get the question done. So I just have to go through and simplify everything. Leaving the 6 there, 63 is the same as 9 times 7. 9 being my perfect square. 320. Now the bigger the numbers are, sometimes it makes it a little bit trickier to find your perfect squares, but 320 can be divided by 64. It is 64 times 5. 180 can be divided by 36. 36 times 5. 112 is the same as 16 times 7. And 405 here, that's a pretty big number, can actually be divided by 81. It is 81 times 5. Going through and splitting the surds. Again, this is where some people may be wanting to skip a few of these steps to save them some time, which is always valuable in a test. Alright, so just split each of those apart. Let's square root our perfect squares. 6 times square root of 9 is 3. Root 7 sits after it. Square root of 64 is 8. Root 5. Square root of 36 is 6. Root 5. We have a 2 sitting out the front for this one. Square root of 16 is 4. Root 7. And for our last one here, the square root of 81. Oh, don't write the square root. See, easy to write things you don't mean to write. Square root of 81 is 9. And then I want the square root of 5. Timesing the numbers together, 6 3s are 18. Root 7. Minus 8 root 5. Minus 6 root 5. 2 times 4 is 8 root 7, and 3 times 9 is 27 root 5. Alright, so we have a few like surds in here that we can collect up. 18 root 7 and minus 8 root 7. 18 minus 8 is 10 root 7. And the ones that are left are all root 5, so they all go together. Minus 8 minus another 6 makes a minus 14. And then I want to add 27, which makes a positive 13 root 5. Okay, now it is time for you to practice to see if you can remember the steps. So I've put some instructions down here to help you remember what to do. Step number 1, first of all, you simplify all the surds that you possibly can completely. And second step is to collect all the like surds together. So I want you to grab a piece of paper and a pen and pause the video, have a try at these 3 questions, and then unpause the video and we'll go through the answers together. So let's do the answers. Here we have our first question, 3 root 7 minus 5 root 7 plus 4 root 11 minus root 11. Well, 3 root 7 and minus 5 root 7, they are like surds. So 3 minus 5 is minus 2 root 7. And 4 root 11 and minus root 11, they are like surds. This would be a 1 here because there's no number. 4 minus 1 is a positive 3, so 3 root 11. Let's have a look at the second question. These ones, there's a few in here that we need simplifying. The square root of 63 is the same as 9 times 7 plus 2. Now root 7, that can't be simplified, so we'll just leave that as it is. Minus square root of 28 is the same as 4 times 7. On the next line, let's split the surds. So square root 9 times square root 7 plus our 2 root 7 still sitting there. Root 4 times root 7. Okay, and square root the perfect squares. So square root of 9 is 3 root 7 plus 2 root 7. Square root of 4 is 2 root 7. So they're all like surds now. So 3 root 7 plus 2 root 7 minus 2 root 7, well those two cancel each other out. So we just have 3 root 7. How are you going? Did you get both those 2 questions right? Let's have a look at the third one. Square root of 125. Well, 125 can become 25 times 5. 294, have a look through your perfect squares, can be divided by 49 times 6. 45 is 9 times 5. And 24, we need a perfect square. The only perfect square that will go into 24 is 4 times 6. So let's split those apart. 25 root 49 times root 6, root 9 times root 5, minus 3 root 4 times root 6. Okay, the square root of 25 is 5 root 5. Square root of 49 is 7 root 6. Square root of 9 is 3 root 5. And the square root of 4 is 2, so I have 3 times 2, which I might go straight to 6 there. 3 times 2 is 6, root 6. Looking for like surds, 5 root 5 minus 3 root 5 makes 2 square root 5. And 7 root 6 minus 6 root 6, 7 minus 6 is 1, which is just root 6. Alright, there we have it. There's the answers. Hopefully you got all those right. It's time for you to go and do more practice on your own. Always do lots and lots of practice. The more practice you do, the better you'll get. So keep practicing and come back for my next video on surds. See you next time.